Good day, everyone. Today we will explore the lesson 1 from our Math 11 course, What is Mathematics? This lesson will help us understand not just what mathematics is, but where it came from and how it shapes the world around us. In this lesson, we'll look at the definition, scope, and origin of mathematics. Mathematics is more than just a number. It is a language of logic, a system of pattern, and a tool for understanding life itself. By the end of the discussion, students are expected to describe what mathematics is, explain its origin, and appreciate how it continues to evolve. When we first learned about mathematics in school, we were taught to calculate, solve, and memorize formulas. But mathematics goes far beyond solving problems in paper. It's a way of thinking. As future educators, it is important for us to understand the deeper meaning of mathematics, not just to teach it, but to help others appreciate its beauty and purpose.
Mathematics is defined as a science that deals with logic, shape, quantity, and arrangement. It is everywhere. In our phones, our money, our buildings, even in the sports we play. The word mathematics comes from the Greek word mathemata, which means that which is learned. This tells us that mathematics is not only about numbers, but about learning and understanding patterns and reasoning.
The root of mathematics. The term mathemata originally referred to any subject of instruction or study. The word mathemata, it came from Greek. It meant learning or knowledge. In general, that it's just not numbers, but in any field of study. The Pythagoreans were among the first to use the term to describe arithmetic and geometry. And the followers of Pythagoras were the first to narrow the meaning of mathemata to focus specifically on mathematics, such as numbers or arithmetic and shapes or geometry. This historical use connects mathematics with both learning and discovery. This showed that mathematics has always been seen not just as memorization, but as a way to learn and make new discoveries. The origin of mathematics. The mathematics originated from practical problems of counting and measuring. Math began because early humans needed ways to count objects and measure things in life or daily life. It can be traced back to ancient Egypt and Babylonia about 3,000 to 4,000 years ago. The earliest records of mathematical use come from the ancient civilization like Egypt and Babylon thousands of years ago. Early humans developed math to enumerate livestock, trade goods, and track time. People first used math for practical tasks such as counting animals, managing trade, and keeping track of days of or season to track seasons.
Early evidence of mathematics. In Egyptian, geometry was used to measure farmlands after floods. The Babylonian developed number system for business and astronomy. Meanwhile, civilization in China and India developed arithmetic and algebra, showing that mathematical thinking was happening all over the world, even in ancient times.
Mathematics as a growing discipline. Mathematics grew together with civilization. It was used in accounting, architecture, astronomy, and engineering. We can think of mathematics growing like a tree. It began with a single seed and branched out into many areas as human knowledge expanded.
So to continue, we are going to discuss about the four basic components of mathematics. So mathematics is made up of four main parts that work together to help us understand numbers, patterns, and world around us. So number one is arithmetic, deals with numbers and basic operations. So this focuses on working with numbers and basic operations such as addition, subtraction, multiplication, and division. It's the foundation of math skills, of all math skills. So an example is when you calculate your total expenses for the week, you're already using arithmetic. Another example is solving 8 times 6 is equals 48. Is also an arithmetic operation. Number 2 is geometry. Study shapes, sizes, and spaces. So this part studies shapes, sizes, and the space around us. It helps us understand that how different forms fit together. An example is when you measure the area of your classroom floor, you're already using our geometry. Another example is identifying a triangle, square, or circle is part of geometry. The third one is algebra. Uses symbols and letters to represent numbers and relationships. This uses symbols and letters like X or Y to represent the unknown numbers and show relationships. So it helps us solve problems more generally. An example is solving x plus 5 is equals 10. To find that x is equals 5 is already a algebra. Another example is using formulas like area is equals length times width to find the area of rectangle. Is also an algebraic thinking. The fourth one is mathematical reasoning, logical thinking that connects all areas of math. So this means thinking logically and carefully to connect ideas and find solutions. It's about explaining why something works. So an example is when you check if your answer makes sense after solving a problem, like using therefore after the correct answer or the solution, that's already a reasoning. Another example is figuring out the fastest way to get to school by comparing routes involves logical reasoning. So to conclude, therefore, these four areas work together to build a strong foundation in mathematics, helping us apply math in real-life situations and higher level of learning.
So, good morning everyone. I am the next presenter. I will be explaining the expansion of mathematics. What is expansion of mathematics? It's the continuous growth of mathematical knowledge, driven by new discoveries, branches, and application. It involves increased abstraction, globalization, technological advancement, and collaboration across various fields like physics, engineering, computer science, and economics. So, for expansion of mathematics, there are four basic arrows modern branches. Number one, calculus, for motion and change. So, there are three examples of calculus. Number one, limit. The foundation of calculus describe the value that a function approach as a input approach some value. Number two, functions. A relation between input and output value. Number three, derivatives. Measure the instantaneous rate of change of a function. It represents the slope of the tangent. So for number two, probability and statistic for data and prediction. So probability help us understand what should happen in the long run given a certain setup, while statistic help us understand what did happen in a sample and what that tells us about. So for number three, set theory and logic for structure and reasoning. Set theory provides the foundation for logic as logical concepts like proposition, predicates, and truth set can be formally defined using set. Conversely, logic is used within set theory to reason about the set, their operation and properties. And the last one, topology and complex analysis for abstract space and system. Topology is about the qualitative properties and space, while complex analysis is about the calculus of functions involve complex numbers. Both are advanced field in mathematics, building a foundational analysis but exploring very different aspects of mathematical structures. Moreover, mathematics continues to evolve as new problems arise.
Importance of mathematics. Mathematics is not just a subject, it's a tool for life. It helps us make decisions, solve problems, and develop critical thinking skills. From technology and engineering to economic and science, mathematics is a foundation of innovation and progress.
To wrap up, think about these questions. 1. How do you define mathematics in your own words? 2. Do you think mathematics could exist without humans? Why or why not? And lastly, number 3, what branch of mathematics interests you most and why? To summarize, mathematics is more than computation. It's a universal language of patterns and logic. It has ancient roots and continues to evolve as we explore new ideas. As future teachers, understanding the essence of mathematics help us inspire others to see it as a meaningful and creative discipline. And to end this lesson, let me share a quote by William Paul Thurston. Mathematics is not about numbers, equations, or algorithms. It is about understanding. Thank you, and let's continue to discover the beauty of mathematics together. See ya!